Okay, today we're going to talk about a more abstract way of thinking about functions. But first I'm going to do a little review for you just to make sure we remember what functions are. So let's say that we've got our girl Sally here and that she makes $8 an hour for her job. So if we write an equation to represent how much money she makes total, we might do something like this, like y equals 8 times x. Of course, x would represent the number of hours that she works, and of course y would represent the total amount of money that she would earn. The number of hours she works would be x because that's our independent variable, because the total amount that she makes, y, depends on how many hours she works. So this is an example of a function because remember, a function means any particular amount that you have for x. If you put it into the function, it's always going to be paired with the same y. So any x value will always be paired with the same y value. What in the world do I mean by that? And I should also remind you, remember that x values we actually call domain, and y values we actually call range. So basically, if you have an x value, aka a value from the domain, it's always paired with the same y value, aka from the range. What do I mean by that? Well, if I put any value in for x, I'm always going to get the same y value out. So let's say that Sally works for 3 hours. So I'm going to substitute 3 in for x. Well, 8 times 3 is going to be 24. So one solution, remember from back, if this doesn't sound familiar to you, you need to make sure you go back and take a look at this video. A solution to this particular equation is 3/24, because that means if you put 3 in for x, you're going to get a 24 out. You'll also remember from a previous video, these x values are also what we call input. And then the y values that come out as a result are what we call output. Well, let's say that Sally has another week where she works for 3 hours. So I'm going to put in 3 for x again. Well, I'm still going to get 24. Okay, so always, if I put in 3 for x in this function, I'm always going to get out a 24 for y. I can sit here and put in 3 all day long. It's always going to come out to be a 24. So I can sit here and write solutions to this equation with 3 as the input all day. The output is always going to be 24. That's what makes it a function. Same x value, aka domain, also known as the input, you are always going to get the same y value, also called the range, also called the output. Here's a graphical representation of what we just talked about with her hours along the x-axis, the amount of money that she makes along the y-axis. So at 0 hours, she'd make $0. At 1 hour, she would make 8. At 2 hours, she would make 16, etc., etc., etc. I connected the dots, making this a continuous function. Continuous is just our fancy math way of saying that we connect the dots. Remember, the reason we do that is because technically you can have half of an hour and you can have half of a dollar. So these values in between each data point are possible. So that's what makes this a continuous function. So there's another way that you can also, if you've got a graph of something, you can tell right away whether or not it is a function, and it's called the vertical line test. Okay, let me show you how that works. I'm going to write it out for you again. Vertical line test. So what does that mean? That means that you can literally draw a vertical line anywhere through the graph. Actually, I should probably make this a different color so it shows up a little bit better. I can draw a vertical line, so that means straight up and down, anywhere through the graph, and it's only going to hit the graph in one location. So for example, this line right here only hits the function right there. This vertical line right here only hits in one place right there. This one only hits in one place right there. How does that help you to determine whether or not this is a function. Well, let's say we go to some weird, bizarre universe where one day Sally worked for 2 hours and she got paid the $16 that she should have, but then one day she worked for 2 hours and she didn't get paid anything right here. So now of course we know that that wouldn't actually happen. Okay, so that means there's actually two values to graph right here. So she worked for 2 hours one day and she made $0. She worked for 2 hours one day and she made $16. Okay, now the vertical line hits 2 points on the graph. So that means that 1 is a 2, 0. She worked for 2 hours. She got paid nothing. Then she worked for 2 hours another day and she got paid $16. Remember that our rule for a function is that if you have the same x values, it always has to be paired with the same y values. And so same x has got to be paired with the same y values. Well, in this case, we've got the same x. We've got two 2's, but this time the 2 is placed with a 0. This time it's paired with a 16. There is no function on the planet that if you put a 2 in one time, you're going to get a 0, then put in a 2 another time, and you're going to get a 16. So if we changed the situation around to look more like this, forget about the equation, forget about Susie's situation. Okay, let's say that we were just given a graph of her situation. And it looked something like this. Like one day for some reason she worked 2 hours, she got paid nothing. Another day she worked for 2 hours and she got paid $16. Because I put a vertical line directly through those 2 points and it hits 2 places on the graph, this is not a function. And again, the reason for that is because we've got two x values. So we've got 2, 0, and we've got 2, 16. So we've got two of the same x values, but they're paired with two different y values. So that is not a function. Just to show you, because we're kind of used to stuff that looks linear, this is another example that even though it's not linear, that means it doesn't form a completely straight line, this still represents a function. Okay, at day 6 at the bank, I'm going to draw a vertical line straight through here. So day 6 at the bank, we made right here, probably looks like it's around 200 or probably like, between $200 and $360. So whatever that value is right there, there's only one of them at day 6. Okay, at day, if these go up by 3 every time, which is what it looks like, at day 15, there's only one value in the bank account. At day, what looks like maybe 19, or I guess maybe day like 22-ish right here, there's only one day graphed. So we can actually draw a vertical line anywhere through our graph, and it only hits the graph in one place. So even though this isn't linear, that is, it forms a straight line, it is an example of a function, because every x value, in this case like 6 for example, in this case 15-ish, in this case probably like 22-ish, each x value only has one specific y value, or this does what we call passes the vertical line test. So if you can draw a vertical line straight through the graph and only hit it in one spot, it's called passing the vertical line test, and that means that it is a function. Again, the reason for that is because each x value only has one particular y value. Okay, now we're going to move into something a little bit more abstract. So this, we don't have a situation. All that's given to us is a list of ordered pairs. And you'll notice the directions say, determine whether the relation is a function and explain. Okay, a relation is a new word for us, but it's nothing but a set of ordered pairs. Okay, so it's nothing but a set of ordered pairs that are hanging out. That's what a relation is. So if we were to kind of take a look at this here, so remember, in order to be a function, if we have the same x values they have to be paired with the same y values. We don't necessarily need to know what the function is. For example, it could be, y is whatever you get if you do 2 times your x, or y is whatever you get if you do x plus 6. Okay, we might not know exactly what that function is. Depends on, if we look at the relation, we might be able to figure it out. But the only thing that's important is that if we have some of the same x values, they've got the same y values paired with them. So let's take a look at what our domain is here. So we've got a -3, a -1, a 0, a -1, and a 3. So remember our domain. And it's not asking me to write this out, but I'm just going ahead and just kind of making us see here. So we've got a -3, a -1, a 0. I don't have to write that -1 again because I've already written it as part of the domain, and a +3. So this is a function if I have the same x values and they're paired with the same y values. Well, I've got 2 of the same x values right here, but they're not paired with the same range values. We've got a -3, a -1, a 0, a +1, and a +3. In this case, my -1 is paired with a -1, but in this case, my -1 is paired with a +1. There is no such thing as a function that I'm going to put a -1 in for x at one point and get a -1 out, and then the next time I put a -1 in and I get a +1 out. It's impossible. So this is not a function, because there's no way to put in a -1 and get out 2 different numbers. Okay, now you take a second and pause the video and go ahead and try to work this one yourself. However, am going to go ahead and work it. So I'm looking at my x values. I've got a 7, 6, 5, 2, -3, and a -6. Okay, so none of our x values are the same. And when that happens, we don't have to worry about the rule that if we have the same x values or domain values, they've got to be paired with the same y values or range values. So because all of our x's are different to begin with, we don't have to worry about this, and we can automatically say that yes, it is a function. Okay, if I were you, I would pause the video again, take a moment, try to work this one out yourself. However, I'm going to go ahead and work it. So in the first one, we've got a 2, 4, 3, 6, and a -2 in our domain, and they're all different. So I don't have to worry about the same x has to have the same y rule. So I can automatically say that a is in fact a function. So now if I'm looking here, I've got a 3, a 1, a -1, a -3, +1. So we've got 2 of the same x values, which is okay as long as they're paired with the same y values. And they're not. So that means that this is not a function. There is no such thing as any kind of a function that I can put a 1 in for my input and get a 4 out. Then I can put a +1 in and get a 2 out. It's just impossible. I'd just like to make a little side note here that a lot of people get confused about this situation right here. So they're used to the idea that if you have the same x's, you have to have the same y. But some people think, oh, look, here I have all the same y, and the fact that they don't have the same x's means that this is not a function. Okay, the rule does not work that way. Because think about it, there's actually a function. You could do y equals 0 times whatever your x value is. So here if I put in 2 for x, I would get out a 0 for y. So that one works. If I put in a 3 for x, I would get a 0 out. So this one works. If I put a 4 in for x, I would get a 0 out. So that does work. So a lot of people get confused thinking that if they have the same range values or the same y values, they have to have the same x values. And that is not the case at all. Okay, that is not true because there are functions out there where you can start off with different x's but end up with the same y. Another example of that might be something like this. This is a relation, of course. So you could have something like y equals x divided by x, because if I put in 2 divided by 2, sure enough, I'm going to get a 1, so that one works. If I put in 3 divided by 3, I will get a 1 out. Or if I do 4 divided by 4, I will get a 1 out. So again, here's another example of, and if there's actually many more than this, but those are just a few I'm doing. Just because you have the same y values does not mean that you need the same x values. So now we're going to take a look at one that actually has a graph, and you're determining whether or not it's a function. So I'm going to use the vertical line test, where I'm going to draw a straight line vertically through the graph, and let's see if it passes the vertical line test. Well, this line, for example, only hits it in one spot. This one only hits it in one spot, and that one only hits it in one place. So we would say that yes, this is a function because it passes the vertical line test. That means that every time I draw a vertical line through the graph, it only hits it in one location. So now let me show you an example of where it fails the vertical line test. This right here is just one of many examples. So I'll just use this line right here as an example. So I just drew a vertical line, not very straight, but through this graph. And it hit in a couple of, actually, let me go right here where the axis is. That's easier to see. So I drew a vertical line, and it hit the graph right here, and it hit it right here. Here's my vertical line. Okay, the reason that this means this is not a function, besides the fact that it failed the vertical line test, here's why it's not a function. If you look at the ordered pair that represents this point right here, it's 0, -2, because it doesn't go left or right, it just goes down 2. And then this one is 0, +2. Okay, it doesn't go left or right, it just goes 2 up. So here we go. We've got 2 of the same x values that have 2 different y values. So that means that this is not a function. Okay, try this one on your own for a second and see, does it represent a function? However, am going to go ahead and work it. And actually, because all of your x values are different, you don't have to worry about whether or not the same x's are paired with the same y's. So yes, this is a function because all of your same x's are paired with your same y's. Let's look at another one. You take a second. Oops, sorry. Nope, don't want that. Okay, here's one more example. Let's see. You try it out yourself. Pause the video maybe. I'll go ahead and work it though. Again, we've got all different x's, so we don't have to worry about whether or not they are paired with the same y's. So in this case, yes, it still represents a function. All right, so these last two examples, go ahead and pause the video. So we've got two graphs. Notice one kind of goes a little squiggly like this. The other one goes straight across. Decide whether or not they are a function. Pause the video. Try it out yourself. When we come back, and then when you come back, check yourself with myself. I'm actually going to fix this a little bit because I realized, I didn't do the best job here of making that straight. So hang on one second. Make it a little bit straighter. Okay, so let me get rid of this one. And so go ahead and pause the video. Try to decide. So we'll call this graph A. We'll call this graph B. Decide whether or not they're functions. And when we return, we'll see what you think. I'm going to go ahead and work it though. Okay, so vertical line test means I can draw a vertical line straight through and only hit the graph in one place. So I'm trying graph A first. Well, it's all well and good until I put my vertical line straight through here. So notice on this line right here, these are just two random points on this graph that I'm picking. Okay, so the ordered pair for this one would be, if this is our origin, 1, 2, 3, 4, 5. So -5, -2. This one would be -5, +2. Okay, we've got the same x's paired with different y's. So that means that graph A is not a function. Graph B, however, we've just hit it in one place, looking at all of our vertical lines, because it just goes straight across. And I could sit here and make points on this guy all day long. All of my x values are different, which means that I don't have to worry about whether or not I have the same y values to go with the same x values. So graph B is a function.